Good morning, folks. We've got two new studies on problems in climate models. We've got to look at how Venus is changing, and we've got a double in galactic current sheet science as well. We're switching from red 304 angstrom view to the bronze 193, ionized helium to ionized iron, and we see the coronal holes, the departing bright active region, and another one to replace it incoming bottom left. When we look a bit behind that limb with stereo A, we see it's a solid sunspot group, and there's also one behind it on the north. In general, we saw a few little pops from the top of umbral fields and smaller filaments, but no major activity. The only space weather of note affecting Earth is a phi angle shift in the solar wind, that's the blue flip and changing telemetry, and it is preceding the coronal hole stream, which will produce only minor geomagnetic effects today. First up in the articles brings us to problems with carbon and uncertainty. It's that uncertainty that has been identified as crushing the validity of climate predictions, and here, interestingly, they find a net zero carbon budget in the Arctic, but only if you ignore the high uptake events. In case you didn't put that together, that's two things global warming advocates probably wouldn't believe in their dizziest daydreams if it weren't in this paper. So let's move on to the oceans, and we're with the world's #1 climate journal, where they're finding major problems with the bias built into those climate models and advocate for more influence of the oceans. Okay, make that three things. And we're off to Venus. Folks, in terms of its planetary changes, we have mostly been focusing on its surge and maximum wind speed and a bit on its atmospheric chemistry. But we have also briefly mentioned how they weren't sure about its length of day, how fast it rotated, and today we know why. There wasn't a disagreement to be had between the working groups that found different answers in the past. Its rotation speed is actually changing. Well played, Venus. Now we're off to the development of helicity in the galactic midplane electric field. This study looked at a smaller scale than the galaxy, but we know that the tiny lab works can teach us about the supermassive in space. The helicity is part of the Parker instability and formation of the current sheet undulation that also comes along with separating the north and south magnetic sectors of a system, and the wavy ripples always come with it. Just like Earth spends 6 to 12 hours inside the sun's current sheet every 7 to 10 days, the sun takes on the galactic current sheet for about 200 years, every 12,000 years or so. We've seen it activate the nearby stars. Its oncoming has already begun to change all the planets and the sun's helium chemistry, and we're just awaiting the actual magnetic switch and associated shock and plasma pressure fronts. There really is no way to tell if what Voyager detected last year was one of those critical fronts or not, but it came with a surge in the magnetic field. Hopefully more will come out on this data in the coming weeks after this initial announcement by a number of folks at NASA and, interestingly, a number of independent researchers. Meanwhile, we'll keep monitoring Earth's magnetism and the changes on the other planets as well. We greatly appreciate your support. Good reason to catch up on either the